Okay, section 1.8 video, part 3. So want to continue solving. So we've done 4 examples so far, A, B, C, and D. So let's pick up with E. I just wrote the formulas again up here where we could see them. All right, so write this one down. This is an absolute value, but it's not an equation. So it's not absolute value equal. So we're not using this formula anymore. Okay? Absolute value inequality. All right. You say, well, we've got to pick which formula. I'm not ready to do that. Follow the steps. Step 1. Step 1, isolate the absolute value term. It is. Step 2, identify A and identify B. So A is the 2x minus 3, B is the 5. Step 3, now choose your formula. Absolute value greater than or equal. So we're clearly using this formula right here. Don't question it. Don't wonder where it comes from. Just write the formula down. So I'm going to write A less than or equal to negative B. That's just the formula. So write it. Or A greater than or equal to positive B. All right, so let's write that. So see, you're going to have to memorize these 3 formulas. A less than or equal to negative B. Or A greater than or equal to positive B. All right, so what do we replace A with? 2x minus 3. 2x minus 3. This one is a less than or equal. This one is a greater than or equal. Now, what do we put in B's place? 5. In B's place, 5, but that's got to have a negative with it. But notice when you rewrite the problem, you go from 1 inequality to 2. But notice that there's no absolute value symbols. Now solve this one and now solve this one. Okay, how do we solve this? Add 3 to both sides. And divide. Over here, add 3 to both sides. And divide by 2. So, here's what this means. If you pick any number less than negative 1, that means negative 1, negative 2, negative 3, negative 4, negative 5. Or if you pick any number 4 and bigger, 4, 5, 6, 7, 8, 9, 10, 11, and you put that number up here and you work this out, it will be true. But here's what else it means. If you pick a number between negative 1 and 4 and you plug it in up there, it won't work. So the answer to this problem is everything smaller than negative 1, bigger than 4. Now, if you'll look back at the instructions before you wrote down part A, here's what the instructions said. Solve the following. But you'll remember the steps I told you. If we're doing an inequality problem, we're going to graph this on a number line. So I want to do that. Now, you said, well, you didn't graph the others. That's because the other 4 were not inequalities. All right, so how do we graph this? All the numbers less than or equal to negative 1, be a bracket on negative 1 going to the left. All the numbers greater than or equal to 4 would be a bracket on 4 going to the right. So you say, Mr. Ryan, I got a question. Anytime we use that formula 2, is the grouse always going to be in the opposite directions? Yes, always. That's why it's got an or statement. You're going to go less one number and bigger than the other number. So there's the graph. Now we will also do the interval notation. The interval notation to this one would be negative infinity, comma, to negative 1. And now put those graphs on the same number line. And then this interval notation is from 4 to infinity. And I think he either will put a comma separating them, sometimes he puts a union symbol in between them. But anyway, that's the answer to that problem. Okay? Let's do another one. Okay, here we go. Step 1. Isolate the absolute value term on a side by itself. So, to get rid of the subtracting 2, you have to add 2 to both sides. And 1 plus 2 would give me 3. Step 2. Identify A and identify B. Step 3. Choose your formula. Okay, the way you decide which formula you're using is the symbol. It's not an equal, so we're not using this one. It's a greater than, so we're going to be using this one, but we're going to take off the equal to. Remember I said earlier, this formula is really 2 in 1. It's a greater than or equal or just greater than. This is less than or equal or just a less than. So if it's just greater than, no equal to, you're still using this formula. You just take off the equal to's. So I'm going to copy that same formula. So it's the same formula we just did in the previous problem, but you take off the equal to's. Now replace A with 5 minus 3x. This one's going to be a less, this one's going to be a greater. Replace B with 3. Replace B with 3, but that's got to have a negative in front of it. Now, notice no absolute value symbols. Solve this one, solve this one. Subtract 5 from both sides. And when I divide by the negative 3, I get x is greater than 8 over 3. Okay, now, let's do this one. Subtract 5 from both sides. But when I divide by the negative, I have to flip the symbol here to 2/3. All right, so let's draw the graph now. All right, let's graph this one first. All the numbers greater than 8/3. Now, if you don't know where 8/3 is at on the number line, approximately, take your calculator and change it to a decimal. Now, I don't want the decimal answer. But 8/3 is about 2.6. So that means that's in between 2 and 3, but it's a little over halfway because 2.5 is halfway. So 8/3 would be about right here. Put a parentheses, you're going greater, so you're going to the right. Now, x less than 2/3. If you don't know where that's at, take your calculator, that's about 0.6. So it's a little over halfway between 0 and 1. So 2/3 would be about there, parentheses, going to the left. Now let's do the interval notation. And this is why I like to graph it before I do the interval notation. The interval notation would be from negative infinity to 2/3, parentheses, comma, 8/3, comma, infinity. Don't use the decimals in here. It won't accept it. Now when you list the interval notation, you have to list the less than one first. So even if I didn't ask you to graph it, it's got to be in this order. So formula 2 is always this way. Okay? Let's look at the next example. Absolute value of x plus 5 less than or equal to 2. Okay, step 1. Get the absolute value by itself. It is. Step 2. Identify A and B. Step 3. Choose your formula. Okay, the formula here, absolute value. Absolute values by itself. This is not an equal, so we're not using the formula 1. This is less than or equal, so you're not using formula 2. Less than or equal to, you're using formula 3. Now notice when you copy formula 3 down, notice the word or does not appear here. This is not a two-part problem like the top two are. So here's the formula. I'm going to copy it down. I'm not going to question it. I'm going to copy it down exactly as it is. If you will notice, this is what we talked about earlier at the very beginning of this section. This is a compound inequality because it has two symbols. All right, so here's what we're going to do. Replace A with x plus 5. So that goes in the middle. Replace B with 2. Replace this B with 2. But this B has a negative in front of it. Now, how do we solve this problem? Well, you've got to get the x by itself in the middle. How do we get the x by itself in the middle? You have to get rid of the adding 5. To get rid of the adding 5, what are you going to have to do? Subtract 5 from the middle. So when you subtract 5 from the middle, it just leaves x. But don't forget, you have to subtract 5 from the number that's on the left and from the number that's on the right. Now, I subtracted 5 in the middle. It just added out. So this would be negative 7 less than or equal to x less than or equal to negative 3. So this graph negative 7 and negative 3 are there. Remember, a compound graph is everything between your two numbers. No arrow on your graph. A bracket on the negative 7 and the negative 3 because of the equal to's. The interval notation is everything from negative 7 to negative 3. Okay, let's do one more. Okay, step one. Get the absolute value on a side by itself. It is not. If you don't do this first, it throws off the entire problem. Step two, identify A and B. Step three, now determine the formula you're using. This is absolute value. This is absolute value less. So you're not using formula 1, you're not using formula 2. It does match with formula 3, but this has an equal to. So what we're going to do is we're going to use the same formula. We're just going to take off the equal to's. So this one's going to be just like the problem I just worked right above this. You just take off the equal to's in the formula. You take off the equal to's. Now replace A with 2x plus 3. Taking off the equal to's. Replace B with 5, replace B with 5, and it's negative. This is a compound inequality because it has two symbols. So formula 3 will always be a compound inequality. All right, how do we solve a compound inequality? You get the x by itself in the middle. All right, x is not by itself in the middle. I've got 2x plus 3. So first of all, I have to get rid of the adding 3. So subtract 3 from the middle. When you subtract 3 from the middle, the plus 3 and the minus 3 adds out. But don't forget to subtract 3 from that right number and subtract 3 from the left number. So basically we minus 3, minus 3, minus 3. So this would be negative 8 less than 2x less than 2. Then to get rid of the number in front of the x, you divide. Negative 4 less than x less than 1. So what this means is if you pick any number between negative 4 and 1. Now you can't pick negative 4 or 1 because there's no equal to's. But negative 3, negative 2, negative 1, 0, or any of the decimals in between negative 4 and 1, it will make that inequality up there be true. But if you pick anything outside of that, it won't. So notice formula 2, the graph was everything outside. Formula 3 is everything between the two numbers. All right, so this graph is everything from negative 4 to 1, no equal to's, so it will be a parentheses on both, and then the interval notation is everything from negative 4 to positive 1. Okay, so this concludes section 1.8 video. Part 3. This concludes section 1.8 altogether, and it also concludes this entire course. So I hope that you found these videos helpful, and I hope that you're watching these videos before you're doing your homework and taking your notes. So next video will be the review.